Okay, here is the first of 4 videos. I decided to just break it down so that the videos won't be too lengthy. So here's the first part. It's the introduction. So we're going to start this off with, again, just copy this into your notes. Okay, worksheet 1. This was worksheet 1 for, we're still using trigonometric ratios, but we're going to abbreviate trig ratios. Right, sine, cosine, and tangent. Using this to find missing sides. Using trigonometry and right triangles to find missing sides. Okay. So copy this into your notebooks. Okay, so this first part, introduction, I'm going to go over some kind of basic stuff, but more importantly on this last part of the video is how you're going to use your calculator and those sine, cosine, tangent buttons. So definitely pay attention. Okay, here we go. So this introduction, you will have, let's see, how to label sides of a right triangle, right? This is right? These trig ratios can only be applied on right triangles. How to label sides of a right triangle using AB. Well, you're going to have uppercase or capital letters. Right, capital letters. And then lowercase. And that's really important to understand. Okay, so real quick. Even if it's very, very simple, some people can get a little bit confused. For the examples that you're going to see, let's draw a right triangle here. Right triangle has a 90-degree angle. The assignment will say that C, this letter C, is a right triangle. I'm sorry, a right angle. Now that's not always going to be the case. Sometimes they'll tell you that A is a right triangle. That means you got to put the letter A. But whichever one they identify to be the right angle, they'll have to tell you. So in this case, it's going to be C. The other two will be A and B. Okay, doesn't matter which way it goes. We'll put the A here and the B here. So pretty much these corners are what these vertices. The vertices of a triangle, right? These corners of the vertices. That's the correct terminology, the correct word. These corners for a right triangle, you always use capital letters. Capital letters. It doesn't matter if it's A, B, C, D, E, F, X, Y, Z. But again, for the problems I believe that you're going to see, they'll tell you that C is the right angle. So in this case, you got triangle ABC, right? You got triangle ABC where what? Where C is the right angle. That's what we're looking at here. What about the lowercase? You can't just put them you can't just put them anywhere. So let me tell you, once you understand that these vertices, these corners of the capital letters, here's what happens with the lowercase. Let me draw this again. You have triangle. We got what, ABC or A, yeah, like this, triangle ABC. If, and again, it doesn't matter, it doesn't have to be ABC, it can be, if you got this, then this is the way you would have to do the lowercase letters. Again, copied exactly the same. If this is true for the corners and the vertices, the capital letters are the corners, then the lowercase, you can't just put them anywhere. It has to be opposite. The angle opposite of capital letter A, the side opposite of capital A is lowercase a. The side opposite of angle B is lowercase b. And then obviously, while across the 90-degree angle, this is capital C, this is lowercase c. So in essence, right, you can't just put ABC and then just put the lowercase ABCs wherever. No, it has to correspond. This angle, opposite of it, lowercase, capital A, opposite, lowercase, capital B, opposite of that, lowercase b, and then the same thing with C. So, uppercase letters are what? Are for what? Blank, I'll put that there. And lowercase letters are for what? Anybody can fill in the blank there? Well, the uppercase letters, the capital letters, are for the what? Not for the corners. I mean, yeah, you put it in the corner, but it's for the angles. The angles. This is angle A, this is angle B. The uppercase letters are for the angles. Angle A, angle B, angle C. What is this? What are the lowercase letter for? This lowercase letter C is for what? For the sides. That's for the sides. And that's the difference. That information is a big deal. Okay, that takes care of, the way you label the triangles. You'll see the capital letters in the corners, and then the corresponding lowercase letters are for the sides. You'll see this on video 4. There's 4 videos. Sides. Lowercase letters are for the sides. Okay, that takes care of that. That wasn't too bad. Okay, good. Now this is the math part. This is the calculator part. Follow here. You're going to think it's super, super easy, but you're going to see right now that it's not. And I'm just going to jump into this right away. Okay. Solving proportions. Because this is coming up and you've learned this in the past. Solving proportions in Algebra 1 and in Geometry and maybe a little bit in Algebra 2. I'll put Algebra 1 and maybe Geometry. All right, so let's see. Example. A proportion is when you have a fraction or a ratio equal to exactly one more other fraction or a ratio. And if you remember this, cross what? Cross multiply to what? To solve. You cross multiply to solve. That's how you solve a proportion. Okay, well, when you have a fraction equal to another fraction or a ratio equal to another ratio. So what does that mean to cross multiply? Not across like this. What they mean by cross multiply is like this, diagonally. So I always start with the one that has the variable, in this case a x. And then you're going to multiply the other two. And long story short, from here it's going to be what? 2 times x equals what? 2 times x equals what? 5 times 4. This denominator with this numerator times this denominator with this numerator. 2x equals what? 20. And then you know how to solve that. Right, that's a proportion. That's easy. That's not using trig. Right now you're going to see the same kind of math, but with trig it's going to look like it's so much different, but it's not. It's exactly like this. Let's do one more example. I got 9 over 3 equals 6 over x. It doesn't matter if the variable's here or on the left or on the top, or in this case I put it over here on the right side on the bottom. It doesn't matter. Right, you cross multiply. So that'll be what? You start with this one. 9 times x equals what? The other one. 6 times 3. All right. Very simple, right? But when you see this with trigonometry, it's not going to be this easy. Keep following along. Next, I'm going to show you how this is also applied in trigonometry. Here you go. So this is going to be 9x equals what? 18, right? 6 times 3, 18. And then we can solve this. We all know we get x equals 2. Okay, we got that. We can cross multiply. But now you're going to see solving proportions with trigonometry, with these functions, with sine, cosine, and these other values that you're going to see. Okay. Solving proportions, what? Involving, here it is. Now we're building up to where we need to be. That's an O. Solving proportions involving what? Now, here we are. We're building up to where we need to go. Trigonometry. Solving proportion using or involving trigonometry, which I'll just abbreviate with trig. Okay, so I'm going to put two problems side by side, and you're going to see that they look like they're the same problem. They're not. And they're not going to look like proportions, but they are. Okay, I'll call this one 1A. I'll call this one 1B. Why? Because it looks like I'm going to use the same numbers and variables and everything, but you're going to see they're totally different problems. Okay, I got sine of 74 degrees equals, and I'm going to put over here also sine of 74 degrees equals. We're good? Same, yes. And on this one, I'm going to put x over 13. And on this one, I'm going to put what? 13 over x. Okay, sometimes the x will be here on the top and the number on the bottom, and then sometimes the x on the bottom and the number on the top. Totally different problems. So follow here. First, you're going to convert into a proportion. Convert this into a proportion would be what? Well, remember, a proportion is a fraction equal to another fraction. I already have fractions on this side. What do I do here? This is not a fraction. Well, just like a whole number, how do you make a fraction? You put a 1 under it. 774 over 1 equals x over 13. First, you're going to convert into a proportion. Yeah? Put a 1 under it. I want to see a fraction equal to another fraction. Right? Change it into proportion. Convert to proportion. Same here, right? Convert to proportion. Now we solve. We solve a... How do we solve a proportion? Solve by what? Cross multiplying. Solve by cross multiplying. Let me write this over here because it's going to get sloppy here. Okay, and I'm just going to finish this and then I'll come back over here. When I cross multiply, remember I said I start with the variable? I start with the variable. And when I start with the variable, I'm going to get 1 times x equals what? (13) times the sine of 74 degrees. All right. Well, this is a good one. This is an easy one. This is one of the easiest of these two. Because what? Right here, 1 times x is just simply what? X. X is already solved right there. It's already solved for x. And then here's where the problem begins, because now how do you do this in the calculator? You have to do this in the calculator. How do you do this in the calculator? 13 times sine of 74 degrees. All right, it's already solved for x, and then I just got to multiply these two parts. Well, if you have this type of, it doesn't have to be this specific one, but if you have a calculator that works like this, and you can see it, because you can just simply write this in like this: 13. Oh, by the way, make sure you're in degree mode. Make sure you're in degree mode. Another way to check and make sure that you're in degree mode, if you put 30, if you hit 30 and then sine, oops, nope. If you hit sine of 30, if you figure out sine of 30, it should give you 0.5. It should be 1/2. That's how you know in degree mode. Or your calculator down here or up here will say DEG. If not, you got to change the mode and make sure you change it to degree. That's another reason you'll get a bunch of things wrong. Okay, but anyways, if you have this one, it'll be 13 sine 74. And then you hit enter. Boop. That's the answer. 12.4964. They're going to ask you to round it to the nearest tenths, which is this first number. They just want one number after the decimal place, so the 9 rounds it up, right? So this is actually x equals 12.5. What if you don't have this calculator? Well, then you got to do it this way. You have the one that I can't put 13 sine and then what was it, 74 equals. It doesn't do anything. See, it doesn't do anything. This one you have to actually do the sine of 74 first. But you have the one where you can't hit sine and then 74 equals. See, it won't do anything. This is the one where it kind of works backwards. Remember, I've talked about this before. Some calculators, the way you push the buttons is different. So I actually have to do 74, then sine. That's the answer for sine of 74. Then times what? Right? This is times what? Times 13. 13 times this value. So you got to hit times 13 and then hit equals. and you'll get the 12.49. See, you'll get the 12.49, which you'll round up to, right, 12.4964, but we rounded it up to 12.5. All right, let's look at this one. If you get this type of problem, it's going to be straightforward. But this other one here, this is the tricky one. Looks exactly like this. I'm using the 74 and the 13, but watch what's happening here. I set it up as a proportion. Now I'm going to cross multiply, right? When I cross multiply here, right, I set it up as a proportion. I'm ready to cross multiply. And when I cross multiply, look what happens here. I'm going to do the one with the x first. If I do the one with the x first, it's going to say x times what? Sine of 74 equals to what? 1 times 13. See, at this point, when you did that over here, the x was by itself. Here, the x is not by itself. Big difference. Here's where they look like they're the same type of problem, but they're not. Here, how do you solve this? This one was already solved for x, or x was already isolated. This one, it's not. So what you have to do here is x times sine of 74 is equal to what? Well, 1 times 13 is just 13. Well, to solve for x, remember, this is multiplication. So to undo a multiplication, you divide by this sine 74. We want to get x by itself, so that means you're going to divide this out, because this is multiplication. So divide and divide. That'll give you, see, now you got x by itself. Now you're going to get x is equal to what? 13 divided by sine of 74. Over here it wasn't divided, it was multiplied. And then the question is, how do you do this on the calculator? Ugh. Okay, well, again, if you have this calculator here, again, you can just put simply 13 divided by, I would use the parentheses, open parentheses, sine of what? 74. Close it for the 74 here, and close it another one for the sine. You get 13.52. But you're not going to get the same answer as this one because it's a different problem, remember? We got what? 13.52. But you got to round it to the nearest tenth. That's a tenths place. The 2 does not bump it up, so 13.5. What if you have the other calculator? The other calculator would be like this. Remember, this is the one where you got to put the 74 and then the sign, but I got to do 13 divided by. Then, again, I would use the parentheses and put 74 sine, and then close it, and then hit enter. Up, and there it is, 13.52. I'll do that again. 13, right? We're trying to do 13 divided by sine of 74. 13 divided by, and here's the parentheses part. Divided by parentheses 74, because you got to put the degree on this type of calculator first. Then the sign, close it, right? Open parentheses, close the parentheses, then hit the equals or enter. And there it is, 13.5 or 13.52. Okay, so we're going to go over this on when I'm going over the problems as well. Okay, there it is, the intro.